Hi, this is Tim Poffenbarger. I'm a solutions architect with GitLab, and I wanted to run past a few approaches for the construct of microservices and how to share URL endpoints between different projects. Within GitLab, there's a few different options, and I kind of wanted to share what options that are out there today and potentially a lightweight service registry tool utilizing Auto DevOps and a GitLab source code repository. So historically, environment variables, anything that you needed to be, somewhat secret or environment scoped, GitLab CI variables are pretty useful here. And what you can do is in the GitLab settings, you can store secrets. And if you prefix anything with k8s underscore secret underscore, and then the variable name, this will, everything after the k8s underscore secret underscore will get propagated into a Auto DevOps environment. So if you ever want to pass in environment variables and store them into your running applications on Kubernetes, this is a really simple way to do this. And one of the nice things is you can scope these by environment, you can protect them, and there's a few different options there as well. So, this one is for all review apps. Let's go ahead and point a particular URL endpoint to this. And this is, manually defined. Anytime you want to update this, you'd have to update it within the GitLab CI variables. Another option is you could, we're building out or continuing to build out integrations with HashiCorp Vault, and there's nothing preventing you from, storing secrets or environment URLs within HashiCorp Vault. And then based on the JWT, the JOT token, as well as the location of what you're attempting to get, Vault could return those things for you as well. GitLab also provides you the ability to have Helm Charts. So by default, your Helm chart provides you your Docker container is running inside of GitLab or inside of a Kubernetes cluster, and then there's also a PostgreSQL database that's provisioned alongside of your application as well. So that way, there are external services, but there's nothing preventing you from defining a Helm chart that has all of your other project repositories or all of the containers from your other projects referenced within that Helm chart as well. So, upon a review app being provisioned, you could deploy into a single namespace containers from multiple projects and have them interconnected and talking together. And we have quite a few environment variables that you can override, but from the idea of overriding a Helm chart, these are probably the most important ones available. Additionally, you can always roll your own kubectl commands. So there's nothing preventing you from utilizing kubectl rather than Auto DevOps to actually, set up your environment how you see fit. And one of the nice things is you're not namespace, you're tied to a particular namespace, and you can get creative there as well. The idea behind this lightweight service registry is really, let's take for example, you have multiple project repositories, and some of those project repositories have long-lived services. So we have project A, project B, and project C. And there's dependencies between these projects. Project A relies on Project B and Project C. Project C is a fairly long-lived project. It doesn't see a whole lot of changes, so it doesn't make sense to continuously be developing. But Project A and Project B, there are some interdependencies between those two. So oftentimes, what the development teams do is they'll create a feature branch called Feature 123, and that naming convention will be consistent across all the different projects. So branch Project A's branch Feature 123 is synonymous with Project B's Feature 123. Ideally, what would happen is this branch would automatically provision a review environment, and GitLab by default utilizes this branch name as the environment name. And so you have this project A, and it's being deployed out to, there's a review environment deployed out to feature 1, 2, 3, and project B also has a review environment called feature 1, 2, 3. And project C does not, it's only on the master branch. It has no feature branch. So there's a staging environment and a production environment. Now, ideally, we could automatically wire up this review app to point to the review environment associated with feature 1, 2, 3 for project B. And subsequently, given that there is no review / feature 1, 2, 3 environment, we'll just go ahead and rely on staging. So setting some sort of priority in terms of when to use which environment. And maybe even if there wasn't a staging environment, we would automatically go to production. So this is a simple project called, it's a Django web application. So it's written on the Django framework. And you can see that this project just has Auto DevOps enabled, which makes things really simple. Another thing that I'm doing here is I'm storing a K8 secret packed demo service URL, key and value. And the intent here is that when Auto DevOps runs, it's automatically going to provision that environment inside of my review app or all subsequent applications as well. So you can see this by default. This is the Auto DevOps pipeline. So I have a Kubernetes cluster wired up to GitLab. So it's going to build, it's going to do all this testing, it's going to deploy a review application. And if I click on this, you can actually see that it's being deployed out to this review / verifying service registry, which is the branch name. And this is what it looks like. And you can see that this packed demo service URL is the same. It's, this URL that's manually defined from the CI/CD variable, which is nice. But sometimes, again, back to our use case, it would be nice to be able to dynamically support ephemeral environments. So I had this idea of, what if we had this service registry repository that kind of was a source of truth? So let's pretend that we had this registry YAML file, and this registry YAML file had an index of all the projects. So you can see that there's project 1, there's this Django Auto DevOps project, which I was referring to, and this project has some dependencies. So it needs demo sys users, tPoffenbarger, microservices demo, packed demo, and packed provider, and maybe even this bogus app. And anytime that another app relies on these applications, it should be stored as an environment variable called Django Auto DevOps service URL. So that way there's consistency across all applications to make sure that the environment variable is always the same. And this particular Django Auto DevOps application has been deployed into 2 locations. So this Auto DevOps location for production, and then this review environment has also been deployed. And there's 2 other applications. We have this packed demo, and this packed demo is always going to be packed demo service URL, and there's production environment and a review environment. And you can actually see that there's this review verifying service registry and a staging environment. So ideally, this verifying service registry environment would be utilized for to fulfill the dependency between the Django Auto DevOps and packed demo. Whereas the packed provider application has no review environment. So we would always just rely on the staging environment instead. So, and down here we see that there is a defined strategy. So the first order of precedence would be the CI environment name, meaning that if the environment names, this is an environment variable provided by GitLab. If this environment variable, these match, it would go ahead and utilize that URL if it's been deployed out. Otherwise, we're going to rely on staging, and if staging isn't available, we'll rely on production. And what this looks like, I'll go back to that. But what this looks like, rather than having this template Auto DevOps YAML in my Django Auto DevOps project, I'm going to enable this project, demo sys users, microservices, service registry, and rely on the Auto DevOps file there. And that file is fairly simple. It's including the Auto DevOps template, and then it's also adding a little bit of logic before the script. And what's going to happen is this logic is going to utilize this service registry and determine you're using really two primary commands, or it's using bash logic as well as JQ, which is provided by default in our auto deploy image, to parse out and determine which URLs to utilize. So I'm going to go ahead and this is my pipeline, and I'm going to go ahead and redeploy this application. Additionally, one other thing that I did want to call out is within the service registry template that's being used, I have I'm overriding the Auto DevOps Dast environment deploy job, the review job, the stop review job, and I'm also including this register review job. And the intent behind this register review job is to call out to this service registry project and deploy and add to the YAML file. So what it's going to do is it's going to kick off a CI job, and the CI job is going to be picked up by the service registry project. And what it's going to do is it's going to write to this code repository, and it's doing that via a private token. And you could also use a project access token, which is going to be made available in 13.4 in GitLab.com and should be available in 13.3, I believe. So this upcoming release. And so the project token or the private token or personal access token are then being used. And let's see if this review app has been deployed. So hypothetically, if I were to go back out here, I would see there's two service URLs now available. And you can see that this packed demo service URL is pointing to a review app with the same branch. And then the provider service URL is this staging demo, which is, again, because it didn't have a review app associated with it. Additionally, let's see if this automatically kicked off. We're back in the service registry project, and I'm going to register the service. By default, this will run upon completion of this review job, but since I replayed it, it doesn't seem like it picked it up automatically. And again, what's happening behind the scenes here is we're simply, this Auto DevOps file is going to utilize the environment variables from the project and pass those into the service registry project. And that logic is then going to be parsed by Python, and then it's going to update the service registry YAML file. So that way, so now we can actually see that there is a new entry into this service registry YAML file. So now any subsequent environment that relies on the Django Auto DevOps project can utilize this environment URL if the branch names match. Some improvements. So, you could always additionally, so right now this logic is dependent upon a few things. So we have these two need statements. One, it needs the build before it happens. And additionally, it's also relying on the register service job to generate an artifact on the master branch, and then that artifact is what is being used. There's a JSON file that's being parsed within this logic that's then generating K8 secrets variables. You could also utilize a GitLab pages page to host a JSON file that is then parsed. I don't know the best solution there. You could also tie this with a deprovisioning of an environment. So upon deprovisioning of the environment, it automatically gets removed from the service registry. And then you could also provide consumers the ability to state what they need rather than requiring management of what they need in the service registry project. Additionally, you could even use you could pass the JSON web token over as a variable to verify that the consumer is who they say they are. So that way they don't have the ability to modify somebody else's service registry entry. That's it for me. Thanks for your time.